Hello everyone, welcome back to this online class. Today we are going to look at Newton's interpolation techniques, that is Newton forward and Newton backward interpolating polynomials. Now we have this question that in an examination, the number of candidates who scored marks between certain intervals were tabulated as follows. So we have the table of marks against the number of candidates. In part A, we are asked to estimate the number of candidates whose marks are less than 70. Part B, estimate the number of candidates whose marks lie between 70 and 89. Part C, estimate the number of candidates whose marks are more than 30. So this question, this is simply an application of the Newton's interpolation techniques, and we can use either forward difference interpolating polynomial or backward difference interpolating polynomial, or a combination of the two. Now, when you have such kind of a data where you're given some range of the x values, you have to formulate it again, reformulate it so that you have it in a better form that you can apply when constructing the difference table. So we are going to say let marks denote x and let the number of candidates be f of x. So what we do here, you write the given data can be formulated to take the form, formulate the given data or reformulate the given data. So that is step one. Step one is reformulate. That should be reformulate the given data. So when you formulate again, how will it look like? I want to get rid of those intervals. So this is what we'll have. I will have marks, still that is x, and have number of candidates, number of candidates, that is still f of x. So how do we get rid of the interval in the given marks? Look at those intervals. From 0 to 19, how many candidates scored marks between 0 to 19? They are 41. It means those who scored marks below 20 are 41. Now the interval from 20 to 39 means that those who scored marks between 20 and 39 are 62. What about those who scored marks below 40? Below 40 are those who scored below 20 plus those who scored below or simply between 20 and 39. So that's 41 plus 62. So this is how we are going to formulate our new table, that those who scored below 20, from that table it is 41. Those who scored below 40 is 41 plus 62, and that should give you 103. Those who scored below, look at the other column, that is 40 to 59, that is below 60. Now it is 41 plus 62 plus 65. And that should give us 168. What about below 80? That is everything. 41 plus 62 plus 65. 41 plus 62 plus 65 plus 50. That should be equal to 218. And lastly, below 100. 80 to 99, that is below 100. And even those who are below 20, below 40, all those you add them together. So everything added together, that's 41 plus 62 plus 65 plus 50 plus 17 and that should be able to give us 235. So you see we have now reformulated the given table to a form that you can easily use to construct the finite difference table. So the next step is construct the finite difference table. Step 2 is construct the finite difference. FD means finite difference table for the reformulated data. So in our table, we'll have x and f of x and f of x. Let me write f of x here. The horizontal line and the vertical line. So let's start with below 20, below 40, below 80, and below. There's also below 60 and 80, and then 100. So right here, marks below 20. How many are they? That is 41. Below 40, that is 103. Below 60, that should be 168. Below 80, 218. And lastly, below 100, 235. So let's get the first order difference. First order. You decide whether you want to use forward difference or backward difference. You are still going to get the same values. So whether you want to use forward difference interpolating polynomial or backward difference interpolating polynomial. Now let me use backward. So instead of first order, I'll just write the backward difference operator. So the backward of f, when you subtract 103 minus 41, that is 62. 168 minus 103, that is 65. 218 minus 168, that is 50. And finally, 235 minus 218, that is 17. Go to the second order, del squared operating on f. So that is 65 minus 2, that is 3. And the other one is negative 15. And this other one is negative 33. Third order differences. Negative 15 minus 3, that's negative 18. Negative 33 minus negative 15, that's negative 18. So you see, in the third order column, we get the same constant value, so we stop there because now it means the next, when we subtract, we are going to get zeros. So I don't even need this long line. I can write it up to here. That's our final difference table. Now let's answer the questions. In part A, let me take you back to the questions. We have to estimate the number of candidates whose marks are less than 70, even before we answer the questions. Since the values in the third order column are constants, it means our polynomial is of degree 3. So you can write, since the values in the third order difference column, third order difference column are the same, the interpolating polynomial polynomial must be of degree 3. So that is P3 of x. So we say P3 of x is equal, because we talk of backward is f0 plus s backward of f0 plus s plus 1 over 2 factorial, second order backward of f0, and then lastly plus s plus 1, s plus 2 over 3 factorial, third order backward of f0. So that's the polynomial we are going to use to be able to answer those questions. That is our Newton backward difference interpolating polynomial of degree 3. So I hope you've taken note of that. Now, let's go to part A. We need to estimate those who scored marks below 70. So in part A, candidates who scored below 70, who scored marks below 70. So locate where below 70 is. You see 70 is somewhere here. This is where we have below 70. Below 70. So that is, it means we need the value of f of x. So we need to estimate f of below 70. F of below 70, what is it? That's the question. So let x be 70. Let x be 70. Now, because of backward, our x naught will be a value that is just below 70 there. That's, you see 70, there's 80, there's 100. A value greater than 70 in that table. Let's use 100 as our x naught. So our x naught will be 100. X naught, take it as 100. Now, we need h, the step size. Look at below 20, go to below 40, go to below 60. What is the spacing? It is 20. It is uniform because 20 you add to 40, to 20 you get 40, you add to 40 you get to 60, and so on. So our spacing is 20, which is uniform spacing. And so therefore, the transformation, which is s, is equals to x minus x naught over h. That is 70 minus 100 over 20. And so that will give you negative 30 over 20, negative 3 over 2. That's what we have, which is negative 1.5. Negative 1.5. So now let's substitute into our polynomial, the interpolating polynomial. But before then, let me explain this term. Because this is x naught, this will be our f naught. This one here will be backward of f naught. This other one will be second order backward of f naught. And this one is the third order backward of f naught. Remember how we were reading the values along a line that is sloping upward when you talk of backward difference interpolating polynomial, or simply backward difference table. Now, it means now we can read this from the table f naught. We can read backward of f naught, second order backward of f naught, you can read it, and third order backward of f naught, you can read from the table. And you also have your value of s, so let's substitute. So you can say therefore f of below 70 is approximately equal to f of below 70 is approximately equal to P3 of 70, and so that is equals to, and let me write this other side, that is equals to F naught, that is 235, plus negative 1.5, delta F naught is 17, plus negative 1.5, negative 1.5 plus 1 over 2 factorial. The other one is negative 33, then plus negative 1.5, that is S, negative 1.5 plus 1, then the other one is negative 1.5 plus 2, negative 1.5 plus 2. This one you divide by 3 factorial times negative 18. So what is the answer? Press that. That will give you 196 candidates. Those are the number of candidates who scored marks less than 70. That means from 0 all the way up to 69. They are 196. So it means therefore 196 candidates scored marks between, that is between 0 all the way up to 69. So let me write here, between 0 to 69. Or simply below 70. So let's answer part B. Part B, candidates who scored, candidates who scored marks between 70 to 89. 70 and above, all the way up to 89. So what is the interpretation of this interval? When you want between 70 to 89, it simply means that this interval means that I need those candidates who scored marks below 90, below 90. That means 0 to 89, but then you subtract below 70. Below 90 minus below 70. Let me write minus. Marks below 90, we are going to get that, then minus the marks below. You see, below 90 is this interval. Below 90 is from 0 to 89. And below 70 is from 0 to 69. So when you subtract below 70, you'll get between now 70 to 89. So I hope that is clear. Now, already I know below 70, we have found it here to be 196, just this. Now we only need to get below 90. Already this one we have found to be 196. Let's get those who scored marks below 90. So we need to estimate f of below 90. So in this case, you're going to say let x be 90 Our x naught, we still retain it to be 100. Our h is still 20. So with this, we'll find our s, which is equals to x minus x naught over h. That is 90 minus 100 over 20. Remember, it was 20, not 2. So that is negative 10 over 20, negative 1 over 2, which is negative 0.5. So in this case, only s changes to be negative 0.5. Now, when you substitute into the formula, look at our formula, this one. We replace them here, and we have everything. We know the value of s, we know the value of f naught, delta f naught, all the way up to delta cubed f naught. The same values. We only change the s. So you can say, therefore, f of below 90 is approximately equal to P3 of 90, and that is equal to, now, it is f naught, which is 235, plus negative 0.5, delta f naught is 17, plus negative 0.5, negative 0.5 plus 1 over 2 factorial. The other one is negative 33, plus negative 0.5, negative 0.5 plus 1, negative 0.5 plus 2. This is over 3 factorial, and the other value is negative 18. When you press this into your calculator, you need to get 231.75, 231.75. And you see this number of candidates. Can it be a decimal, really? No. So we can approximate this as, this is approximately equal to 231 candidates. Those are the candidates who scored marks below 90. Of course, I've just truncated. Now, if you want between 70 and 89, you subtract the 2. So therefore, f of between 70 to 89 is simply equal to f of below below 90 minus f of below 70. And so below 90, we got it to be 231. Below 70 was 196. And so those are just 35 candidates. Lastly, part C. We need the students who scored marks more than 30 and above. So what does it mean? Let me take you back to the question. Candidates whose marks are more than 30. So this is what we are going to do. You write part C, candidates whose marks are more than 30. That means 31 going onwards, more than 30. This means i.e. 31 all the way up to 99, because I can see no one scored 100. So I need marks between 31 and 99. So the interpretation of that interval, 31 to 99, means that it is, let me write it here, 31 all the way up to 99. The interpretation of this interval is those who scored marks below 100 minus those who scored marks below 30, below 30, 31 I mean. What do you mean by below 100? That is from 0 to 99. Below 31 is from 0 to 30. So that means when you subtract the two, you are going to get between 31 to 99. I hope that is clear. So do the same below 30 and also below 100. Already we have below 100 in the table. Those who scored below 100 are 235. That is okay. So from the table, f of below 100 is equals to 235. So I need f of below 31. So now estimate f of below 31. So what happens here? You let x to be equal to 31. Our x naught is still 100 because we are using backward difference. Our h is still 20. And so therefore s will be equal to x minus x naught, everything over h. That is 31 minus 100 over 20. That is it 70? That's 69 over 20. That's our s. So let us go back to the table and even our polynomial and substitute f naught, delta f naught up to delta cubed f naught, and even the s in that polynomial. So you can just say that therefore f of below 31 is equals to, that is f naught, which is because it is p3 of 31, which is equals to, let me write it here, that should be equal to, so we are going to read the values from the table because we have everything. So this is the value we get at P3 of 31 as 73. Now when you subtract from that of below 100, you get 162 candidates who scored marks more than 31. So thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof Francis Okech and you will find me right there. Also, don't forget to comment, like, and share this video. Bye-bye.